Under Geneva's cloak, on the surface of the Earth, lies a human marvel, resiliency and potential, or perhaps a sign of impending doom for the entire planet. The Hadron Collider, LHC, is an uncommon device for researchers, enabling them to investigate subatomic particles and discover what some call God's secret, the elusive Higgs boson. Brian Cox, a well-known physicist, made a terrifying statement that has shaken the religious community, claiming that a significant event has been discovered at CERN with repercussions that go beyond our current understanding. But before delving into the implications of Cox's assertion, it's essential to comprehend how CERN's Large Hadron Collider, LHC, works. The LHC is a 17-meter-wide superconducting magnet ring, the most powerful particle accelerator in the universe. It is the pinnacle of human achievement, capable of replicating the conditions at the moment of the universe's creation. It allows us to discover the mysteries of existence. CERN, established in 1954, is one of the most prestigious scientific institutions in the world, consisting of 23 member states and a wide array of higher learning institutions. The LHC is the focal point of this collaborative effort. However, it is just one component of an extensive network of accelerators and detectors designed to study the subatomic world. As protons are accelerated to the speed of light, scientists aim to recreate the universe's energy at the moment of the Big Bang, generating temperatures millions of times hotter than the core of the Sun. A complex arrangement of magnets directs these protons as they travel, while modern cooling techniques maintain the collider at temperatures colder than the vacuum of space. The LHC, a marvel of space engineering, operates underground, shielded from cosmic radiation. Collisions occur at 4 points along the corresponding accelerator rings, in front of 4 principal particle detectors: ATLAS, CMS, ALICE, and LHCb. These detectors record the effects of collisions, allowing researchers to sift through the debris in search of the elusive Higgs boson, a particle that holds the key to understanding the universe's structure. The LHC is not only a scientific instrument but also a symbol of human imagination and ambition. It represents our thirst for knowledge and our desire to understand the fundamental forces shaping our universe. However, as we test the limits of understanding, we must also consider the moral and existential questions that arise. What are the risks of exploring the unknown? Could our quest for control unleash forces beyond our command? In the sanctified halls of CERN, the frontiers of human knowledge are constantly expanding. A recent revelation sent chills down the spines of even the most rational scientists. Brian Cox, an experienced and respected CERN researcher, made a statement that astonished and terrified the scientific community. The LHC's objective, he said, is to recreate a scaled-down version of the Big Bang, the very event that gave birth to our universe. Cox highlighted the possible outcomes of such an experiment, including the LHC's extraordinary capacity to reveal new phenomena, such as the study of dark matter, a substance that makes up a substantial portion of the universe. The idea of creating a miniature Big Bang is no longer theoretical, it is a tangible reality within the LHC. The conditions in the collider closely resemble those at the universe's inception, giving scientists a chance to observe the very beginning of existence. Yet with such power comes immense responsibility. Consider the case of Anatoly Bugorsky, a Russian physicist who, in 1978, suffered a mishap at a high-energy physics institute. Due to an error, his head intersected with a beam of protons. Despite severe injuries, he survived and continued his work, underscoring the enormous power and danger of particle accelerators. The risks posed by accelerators like the LHC should not be underestimated. Among the concerns expressed by scientists is the possibility of the LHC producing tiny black holes, regions of spacetime with such strong gravitational pull that not even light could escape. Even if created on a small scale, such entities could potentially pose catastrophic risks to the Earth. However, CERN scientists have publicly assured that any black holes formed would evaporate almost instantly. Understanding how the LHC operates involves fundamental particle mechanics. When protons are smashed together at nearly light speed, the energy levels are so intense that spacetime itself could, theoretically, warp. One can imagine spacetime as a taut trampoline. Placing a weight on it causes a warp. If the weight is great enough, the surface collapses. This analogy illustrates the potential of the LHC to create gravitational anomalies. This concerning possibility has even caught the attention of the late physicist Stephen Hawking. In his writings, Hawking warned that the Higgs boson might become unstable at extremely high energy levels, potentially resulting in a disastrous vacuum decay, a catastrophic event capable of destroying the universe. Respected cosmologist Sir Martin Rees also voiced his concerns in his book Our Final Century, where he explored the future risks of particle collider research. One such concern is the unpredictability of vacuum stability. A small disturbance could initiate a phase transition that ripples across spacetime with unimaginable consequences. Despite the remote probability of such disasters, the stakes are so high that even the slightest risk must be taken seriously. CERN has put extensive safety measures and protocols in place to minimize potential dangers. While scientific exploration demands a certain level of risk, it is this very willingness to defy limits that has fueled human progress for centuries. The LHC is the culmination of decades of international collaboration and scientific advancement. Yet, it operates in a realm where profound potential meets ethical concerns. Its primary goal is to unravel the mysteries of particle physics, and it has already led to remarkable discoveries, chief among them, the Higgs boson. However, the colossal energies involved also raise the question, could such discoveries come at a cost? While safety procedures are stringent, and black holes are unlikely to form, anomalies cannot be entirely ruled out. As studies continue to push the boundaries of human comprehension, it's critical to approach these ventures with awareness of potential outcomes and a commitment to transparency and public discourse. The LHC's unmatched capabilities and potential for revolutionary discoveries are a testament to human ingenuity and our relentless pursuit of the fundamental laws of the universe. But beneath this awe-inspiring exterior lies a world of intricate science, risk, and ethical debate. The collider experiments manipulate forces and energies beyond the grasp of ordinary people, smashing subatomic particles at light speed to replicate the earliest moments of the universe, and, in doing so, probing the very fabric of spacetime. The immense energy involved also brings critical dangers. One of the most pressing issues is the possibility of creating exotic phenomena, like micro-black holes, with unforeseen consequences. Although theoretical models indicate such entities would vanish quickly and pose no threat, the unease surrounding potentially uncontrollable forces remains. Given the collider's scale and complexity, rigorous safety procedures and oversight are essential. This discovery not only cemented the Standard Model's place in modern physics but also opened new questions that venture beyond known science into uncharted territory. While the Higgs boson confirmed the existence of a fundamental mechanism giving mass to particles, it left gaps in our comprehension, particularly regarding gravity, dark matter, and the unification of forces. Dark matter, for instance, makes up approximately 27% of the universe, yet it remains invisible and undetectable through direct observation. The LHC's experiments may be one of the few tools capable of shedding light on this mysterious substance. The hope is that, through high-energy collisions, scientists might uncover new particles, supersymmetric partners or other exotic forms of matter, that could explain dark matter and even dark energy. However, this frontier comes with ethical implications. As we approach energies and phenomena that echo the universe's origins, some philosophers and physicists have argued that our experiments might be treading into realms with consequences we don't yet understand. The sheer ambition of recreating the conditions of the Big Bang is staggering, magnificent to some, but potentially reckless to others. The notion that a scientific project could affect reality on a universal scale may seem like science fiction, but when dealing with forces that shape the cosmos, prudence becomes imperative. The fears of creating microscopic black holes, vacuum decay, or other spacetime anomalies, while extremely improbable according to current models, highlight just how far beyond the familiar this research reaches. At the heart of this concern is a paradox. To better understand the universe, we must probe it in ways that could potentially alter it. The scientific community thus finds itself in a constant balancing act, between curiosity and caution, between risk and reward. CERN's scientists have long acknowledged this, and the organization remains one of the most transparent and safety-conscious research institutions on the planet. Every experiment is carefully reviewed, modeled, simulated, and debated before implementation. CERN has issued multiple public safety reports, confirming that the energies produced in the LHC are still far lower than those occurring naturally in the universe, such as from cosmic ray collisions in Earth's atmosphere, which happen constantly without destructive consequence. Still, public concern persists. The LHC has inspired conspiracy theories, public protests, and even legal actions attempting to shut it down. Some fear that our technological capacity has outpaced our ethical readiness. But others argue that fear should not paralyze progress. They point to the enormous benefits already reaped, the development of the World Wide Web at CERN, advances in medical imaging and cancer treatment, and the very expansion of human knowledge. Ultimately, the Large Hadron Collider is not just a machine, it is a symbol. It stands as a monument to what humanity can achieve when we unite across nations and disciplines in pursuit of a deeper truth. It challenges us to confront the unknown, to grapple with cosmic questions, and to accept the responsibility that comes with wielding such power. What lies ahead for the LHC and future colliders, like the proposed Future Circular Collider, FCC, which would dwarf the LHC in size and power, is uncertain. But one thing is clear: we are at the dawn of a new era in physics. An era where the questions are bigger, the risks are higher, and the rewards could redefine existence itself. Whether the ultimate outcome is discovery, danger, or both, our journey into the subatomic world continues. It is a journey that demands both awe and caution, a scientific odyssey written not just in data and collisions, but in the spirit of exploration that has always driven humanity forward. The universe's fundamental structure, on the other hand, like with all important scientific efforts, is something researchers try to learn as much as possible about. The LHC has potential, but not all of it is fully understood. Energy-related dangers and ethical dilemmas are involved in collisions between particles. The potential of the LHC is enormous. Generating new materials or unexpected reactions cannot be completely ignored. Some researchers have envisioned scenarios in which collisions of high energy could result in tiny black holes or other bizarre substances, raising questions about the possible outcomes of such events. The majority of scientists, however, believe these risks are extremely remote. The nature of scientific inquiry necessitates venturing into the unknown. Brian Cox's assertion that it may be possible to replicate a miniature Big Bang in the LHC highlights both the profound significance and potential dangers of such research. The study of the Large Hadron Collider symbolizes the pinnacle of contemporary scientific endeavor. Despite its extraordinary capabilities, it also elicits critical discussion about limitations and scientific responsibilities. The goal of both the design and operation of the collider is to investigate fundamental issues regarding the universe. Nonetheless, it operates at the frontier of human technological capability and knowledge. This intersection brings up significant concerns regarding the nature of science and the ethical ramifications of risk. Such cutting-edge research is one of the most exciting aspects of the LHC. One of the LHC's most fascinating features is its ability to precisely recreate the conditions that existed minutes after the Big Bang, a remarkable look at the beginning of the universe that can now be simulated. Scientists can investigate particles that existed in the universe's earliest stages and examine phenomena that would otherwise be impossible to access. By replicating these extreme circumstances, researchers are able to test hypotheses and fine-tune models, including those from particle physics. The LHC experiments have the potential to investigate the characteristics of hypothetical dark matter particles, which are thought to constitute a significant portion of the universe's mass, yet remain hidden from conventional detection methods. The investigation into dark matter is driven by its profound effects on our current understanding of the universe, which remains hazy. Dark matter can be deduced from its gravitational effects on visible matter, however, direct detection remains elusive. This is one of the focuses of LHC experiments, which attempt to create dark matter particles in a laboratory. If successful, this could dramatically change our understanding of the universe and lead to brand new discoveries and insights. The LHC serves both as a scientific instrument and a driving force for revolutionary discoveries that could alter our perspective. Another intriguing area of research is the study of one of the four fundamental forces of nature, the strong force, which binds protons and neutrons within the nucleus of an atom. Comprehending its high-performance energies can yield insights into the fundamental elements of matter. The LHC's capacity to investigate powerful forces allows researchers to study interactions at unprecedented scales, including the relationships between gluons and quarks, the fundamental mediating particles of the strong force. The results of these investigations could lead to greater comprehension of nuclear physics and the factors that influence the behavior and properties of atomic nuclei. Technological advancements driven by the LHC have far-reaching effects beyond complex particle physics. The collider systems for analyzing and detecting particle couplings have sparked innovations in computer science and sensor technology. For instance, the growth of the Internet worldwide was originally spurred by the need for researchers to share particle data. Today, technology born from physics experiments at CERN has transformed global information dissemination and communication. The advancements in data and computing management necessary for the LHC have had a cascading effect across various fields, demonstrating how significant scientific research can drive technological progress. However, the operation of such a powerful instrument also requires strict safety regulations and ethical consideration. The potential for unexpected outcomes, such as the creation of exotic or new particles, demands thorough risk assessment. While theoretical models indicate that the likelihood of catastrophic events is extremely low, the possibility cannot be entirely ruled out. Because of this uncertainty, researchers must approach their work with caution and transparency to ensure that safety protocols are effective and that the public is informed about potential dangers and the measures taken to mitigate them. Understanding and public engagement are important aspects of scientific research, especially for projects with the potential to affect society at large. The LHC has generated significant public interest and discussion, underscoring the importance of effective communication of complex scientific ideas. Broader science communication that resonates with the public helps demystify research and encourages informed discourse on the consequences and risks associated with advanced scientific experiments. By maintaining open communication with the public, scientists can address concerns, dispel misconceptions, and build trust in the scientific process. As we progress and the LHC continues operating, the potential for new findings raises significant questions about the future of science. Exploring the collider's capacity to investigate previously unknown particle regions may raise new challenges that test the boundaries of our knowledge. Advancing these frontiers will require collaboration among engineers, scientists, and policymakers to ensure that research is conducted ethically and that the benefits of scientific progress are maximized while minimizing potential risks. The LHC stands as a testament to human creativity, engineering, and the insatiable pursuit of knowledge. It represents the convergence of cutting-edge technology, theoretical physics, and international cooperation, a collective effort to understand the universe's deepest secrets. As we continue to investigate the fundamental forces and components of reality, it remains vital to stay vigilant about the ethical implications and possible outcomes of our research. The Large Hadron Collider remains at the forefront of scientific inquiry, offering groundbreaking insights into the nature of the universe. Its experiments have the potential to open new domains of knowledge, drive technological innovations, and deepen our understanding of existence. But with its remarkable capabilities come profound responsibilities. The pursuit of knowledge must be balanced with a commitment to safety, transparency, and public involvement. As researchers push the boundaries of particle physics, the LHC will continue to exemplify human curiosity and the enduring quest to unravel the mysteries of existence. In the years to come, the Large Hadron Collider is expected to evolve, not only in its hardware and technological sophistication, but also in the complexity and ambition of the questions it seeks to answer. Planned upgrades, such as the high-luminosity LHC, promise even greater precision and volume of data, enabling scientists to delve deeper into phenomena that remain on the fringes of modern physics. With increased luminosity comes the possibility of uncovering new particles, forces, or dimensions that could fundamentally reshape our existing models. Questions surrounding the unification of forces, the asymmetry between matter and antimatter, or the mechanisms behind mass itself may begin to find answers in the next generation of experiments. Furthermore, the collaborative nature of the LHC's mission cannot be overstated. Thousands of researchers from across the globe contribute to its experiments, sharing data, resources, and insights. This vast network of cooperation symbolizes the best of scientific endeavor, a world united not by borders, but by curiosity and a shared desire to understand the cosmos. Equally important is the cultivation of the next generation of physicists, engineers, and thinkers. The LHC is not only a research facility, it is a beacon of inspiration for young minds. Through educational outreach, internships, and partnerships with universities, it fosters a culture where innovation is born from passion and dedication. As the public becomes more engaged with scientific discoveries, the importance of transparency and dialogue will only grow. Ethical oversight, thoughtful communication, and inclusive discussion must remain at the heart of major scientific undertakings. The LHC, with its power and complexity, demands not just intellectual rigor but moral responsibility. In the final analysis, the Large Hadron Collider is more than a machine. It is a testament to what humanity can achieve when driven by a desire to know more. It stands on the edge of the known universe, peering into the fabric of space and time, unlocking secrets written into the very code of reality. And as each new experiment unfolds, it brings us closer to answering the most profound question of all: what is the nature of everything?